Example number 2. This graph shows the number of fishing boats N anchored in an inlet in the Queen Charlotte Islands as a function of time. Whenever you're reading a math problem and you notice this weird connection or convention in which a letter is surrounded by commas, it generally is a good tip-off that this is a variable that's being defined. And if you notice, we have two variables, n and t. So I'm just going to read this again, and it should make sense. N should represent something that maybe starts with the letter N. This graph shows the number of fishing boats, N, anchored in an inlet in Queen Charlotte Islands as a function of time, t. Identify the dependent and independent variable. Well, the dependent variable depends on the independent variable. So, may I ask you, does the number of boats on the water determine the time? Or does the time determine, let me say that again. Does the number of boats on the water depend upon the time? Or does the time depend on the number of boats? So the number of boats depends on the time. So the number of boats, N, is going to be my dependent. My time is going to be my independent. And what we should see here is they've given us a graph. If I can just talk quickly about the graph, the horizontal axis will always be the independent. The vertical axis will always be the dependent. Now, this is true for x and y. The independent variable is always the horizontal. The dependent variable is always the vertical. So in this problem, why are the points of the graph not connected? Because the points are discrete. And what I mean by that, we have discrete data. That is, somebody is going out there and reading how many boats there are at 9 o'clock, and then they go out and reading it at 10 o'clock. How many boats are there at 9:31? Well, nobody knows because nobody took the observation. Discrete means it happens at one time or a specific number. And here we really see there's no observations in these time periods. So for instance, we know that the graph could go, that would be wrong. We know that the graph could look like this, or it could look like this. We really don't know because the graph is discrete. So determine the domain and the range. So now the domain and the range, the domain comes from the independent variable, and the independent variable is time. And if I notice, I start counting at 10 o'clock, 11 o'clock, 12 o'clock. Now if you notice, I'm just dropping the o'clocks. 13 o'clock, 14 o'clock, 15 o'clock, and 16 o'clock. Whereas my range is my dependent, or my y values, if we had y values, and here we don't. So I'm just trying to pick off all those values. So what I know is here is my range is going to be 6, 8, 10. We have one point here that has a value of 11 for my dependent, and really domain and range is typically x and y. And it doesn't hurt to maybe, that analogy definitely doesn't hurt. By the way, that's not 12, or that's not 14, it's actually 15 the way that I drew it, and this is 25. All right, so let me look at this next graph here, example 3. This graph shows the approximate height of the tide h meters. Now, h is our variable, and h corresponds to the height as a function of time, t time. So let me read this again. And h is height, t is time. The graph shows the approximate height of a tide, h in meters, as a function of time at Port Clemens. Now, we notice that the graph looks a little bit different. Previously, the points were just points. We didn't connect the dots. Whereas the tide, we would describe it as continuous. We are certain, well, we'll get to that point maybe, and I'll talk about those 2 points. Identify the independent variable and the dependent variable. So does the time of the day depend on the tide, or does the tide depend upon the time? Well, we know that the height depends on the time. So I really have my dependent variable is height. My independent variable is going to be time. And what we can see is, in fact, time is independent, is on the horizontal, and my dependent is the height, is on the vertical axis. Why are the points of this graph connected? Because the data is continuous. Ooh, incorrect spelling there. Got too excited, added an extra E. So in between this point and this point here, now that actually equates between 9 o'clock and 10 o'clock. That is, the tide would have a definite measurement somewhere in between that. The height of the tide would have a level at 9:32. So what is the domain for this? Now, I'm going to write this in 2 different ways. The domain. The domain here is going to describe typically what we would think of as x or our independent variable. And I could say the domain, we're going to define time such that time is stuck between, now let me look, time is between 9 o'clock in the morning and it looks like 14, 15, 1600 hours. So now I'm not going to add that crazy, time is element of the reals business because we're talking about time, not numbers here. And this is totally acceptable. Whereas my range is talking about dependent. Range, the lowest it is here, and the highest it goes up to there. Now let me interpret what those numbers mean. So I guess what I'm trying to say for my range now range is height. So that's the variable. Height exists such that height is between. Now the lowest one that I have, now I have to try to be very careful here. It looks like the lowest height that I have is 0.9. And the highest that I have is 1.5. So here this says height is between 0.9 and 1.5.